Welcome back, math friends. Today we're taking a look at adding with integers, and we are going to be using a model called an algebra tile model, and we're going to be using drawings of algebra tiles to add positive and negative integers. And something that you need to remember when we're doing this is the concept of zero pairs. Now, if you remember from the vocabulary video that we did before, you know that zero pairs are when you have a number and its additive inverse or its opposite, and you add them together and they make 0. For example, 4 plus negative 4 equals 0. So 4 and negative 4 are a zero pair. And today we're going to be using the idea of zero pairs, but we're just going to be using 1 and negative 1 because these will be our tiles that we're using. Okay? So, let's look at our first situation here. It says that Todd borrowed $9 from his brother. He paid him back $4. What is Todd's financial situation now? Does he owe his brother money? Does he have money that so he can spend? Or what's the deal? So let's take a look. We have to write the expression that represents the situation first. Remember that if you borrow money, you borrowed $9, that's a negative number. Anytime you are in debt, that is a negative number. So that's negative 9. But when you pay back money, that's a positive. So negative 9, positive 4. Negative 9 plus 4. Now, when we look at our diagram here, we can see that there are lots of tiles here, and we have negative 9. So we have 9 negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9 negatives, and we have 4 positives. 1, 2, 3, 4. Please make sure that you copy this diagram down, including the algebra tile diagram. Okay? Now, negative 9 plus 4, how much is that? Well, we're going to use zero pairs to figure this out, because when you add zero pairs, they make 0, and so basically they cancel each other out. So let's go through here and cancel out some zero pairs. Well, here's a zero pair, a negative 1 and a positive 1, so they're gone. Here's another zero pair, they're gone. Here's a zero pair, so they are gone, and here's another zero pair, and they are gone. So then when we're all done, what's left in our diagram? Well, let's find out. There's 1, 2, 3, 4, 5. 5 negatives. So our answer is negative 5. 5 negatives. And what does that mean for Todd's situation? Well, that means that Todd still owes his brother $5. And we used algebra tiles to figure that out. All right, let's move on to the next question. Another practice one. Todd was exploring a cave. At one point, he was 8 feet below ground. Then, he climbed 5 feet toward the surface. What is his position now? So we have to come up with the expression, first of all, to represent that. If you're 8 feet below ground, that's a negative number. That's negative 8. But then when you climb 5 feet toward the surface, you are climbing up in a positive direction, so that's positive 5. And our diagram, you can see here, it's not quite as messy as the one in the previous picture, but our diagram has 8 negatives, and it has 5 positives. So, let's go through and get rid of some zero pairs. Here's one, so those are both gone. Here's a zero pair, so those both cancel each other out. Here's a zero pair, so they are both eliminated. Here's another zero pair, so they are gone. Now I still have one positive that I can match up with one more negative up here, so that's a zero pair, so they're both gone. And so then what's left? Well, I have 1, 2, 3 negatives left. So that must mean that negative 8 plus 5 is negative 3. So you can do integer addition using algebra tile diagrams to solve. And what does that -3 mean? Well, that means that he is still 3 feet below ground. Okay. Well, let's take a look at another example. Now this one doesn't have a word problem to go with it. It just says, what is the expression that represents this workspace? Well, what do we see in this workspace? Let's see. What if I count up all the positives first? I have 1, 2, 3, 4, 5, 6 positives. So 6 plus 1, 2, 3, 4 negatives. -4. Now I put parentheses around the -4 because I don't want people to think that it is 6 plus -4. That would be weird. So when I put parentheses around it, I'm separating that number, that integer, -4, from the addition sign. 6 plus -4. Now I could also write this in a different way. I could count the negatives first and say, well, that's -4 plus 6. Either way, it's fine because of the commutative property of addition. I can reverse the order of the addends. Now notice I didn't put parentheses around the -4. I could have, but since it's coming before the plus sign, I don't really need to. Now let's find the value of this expression. Either 6 plus -4 or -4 plus 6. They're both the same. They're going to equal the same thing. Let's cancel out some 0 pairs, people. Here's a 0 pair, so they're both gone. Here's a 0 pair, so they're both eliminated. Here's a 0 pair, so those cancel each other out. Here's another 0 pair, so they're both gone too. And what do I have left when I'm all done? I have 1, 2 positives. So 6 plus -4 is +2. -4 plus +6, also 2. How great is that? So here's the expression. Either one of these is great for the expression, and here's the value of the expression, 2. Fantastic. Let's take a look at one more. Now this one says we are going to model and find the sum of -3 plus -4. Now notice that both the numbers that are in this are negative. -3 plus -4. Okay? Well, here we see -3. Here we see -4. Are there any 0 pairs? Do you see any 0 pairs where you have a positive and a negative that cancel each other out? No, you don't. All you see are 3 negatives and 4 negatives. And so when we add those together, what do we have all together? There are no 0 pairs, nothing gets canceled out. So we just have -3 plus -4 equals -7. Just a bigger bunch of negatives. So there you have it. How easy is that? Adding integers. 0 pairs play a huge part. Unless, of course, there aren't any, then you just add up all the numbers that you see. All right, folks, have a great day. Don't forget to be awesome, and I'll see you next time.